In the deep, silent dark of the planet's crust, kilometers below the familiar cycles of sun and season, a new kind of star is igniting. It is not a star of hydrogen fusion, but one of slow, inexorable fission and decay. These are the deep geological repositories, the final resting places engineered by a short-lived technological species. They were conceived as tombs of perfect stasis, multi-layered fortresses of copper, steel, and bentonite clay, designed to seal away a lethal legacy for 1,000,000 years. The intention was to entomb a poison so completely that it would cease to exist in any practical biological sense. But physics is profoundly indifferent to intention. These tombs are not cold. They are furnaces. Within their nested shells, a relentless process unfolds. A single metric ton of spent nuclear fuel, 10 years out of the reactor, still radiates heat at over a kilowatt. This thermal energy, a constant and unwavering byproduct of atomic decay, seeps into the engineered barriers and the surrounding host rock. The temperature in the repository's core will remain hundreds of degrees above ambient for centuries, creating a permanent thermal anomaly, a bubble of artificial heat deep within the cold lithosphere. This is not a passive warmth. It is a thermal engine, driving chemical reactions, stressing materials, and creating an energy gradient of immense power, a beacon in the profound dark. This energy is not just thermal. It is a landscape of pure, violent physics. The waste is a source of intense ionizing radiation, a storm of subatomic particles. Alpha particles, heavy and slow, are easily stopped but inflict massive localized damage. Beta particles, high-energy electrons, penetrate further. But it is the gamma radiation that defines this environment. It is a form of light, but a light so energetic it functions as a universal solvent for the molecules of life. A person standing unprotected in this core for a few seconds would absorb a dose of thousands of sieverts, tens of thousands of times the natural background radiation. A dose that guarantees death within hours as the body's cellular machinery is systematically shredded. This glare of gamma rays does not just kill, it unmakes. It strips electrons from atoms, creating a cascade of hyperreactive ions and free radicals. The elegant, complex double helix of DNA is snapped like dry spaghetti. The intricately folded proteins that act as cellular machines are denatured, their shapes irrevocably warped, rendering them useless. Cell membranes, the delicate boundaries between life and non-life, are perforated and dissolved. By the standards of the sunlit world above, this deep, warm, radiant place is the most perfect definition of sterile. It is a hell of pure physics, an environment where the laws that govern matter actively prohibit the existence of the complex structures required for life as it is known. Yet, the history of this planet is a story of life conquering one impossible environment after another. It thrives in the boiling, acidic waters of volcanic springs, where temperatures and pH levels should preclude biology. It persists in the crushing, lightless abyss of the Mariana Trench, under pressures that would pulverize any surface creature. Life has been found in the frozen, desiccated valleys of Antarctica and in the thin, irradiated atmosphere miles above the ground. The common thread is not temperature, pressure, or chemistry. It is energy. Wherever a usable energy gradient exists, life has demonstrated an inexorable, almost mathematical tendency to arise and exploit it. Its sole, blind imperative is to find a source of power and use it to build complexity from chaos. And here, in the heart of these man-made underworlds, lies the most concentrated and long-lasting energy source ever created by that same life. It is not just the thermal bleed. It is the radiation itself. For an organism that could learn to harness it, the gamma flux is not a poison but a torrent of pure, raw power. The builders of these places understood the physics of decay, but they operated with a biological blind spot. Their meticulous models accounted for rock mechanics, water tables, and long-term corrosion rates, but they viewed the world through an inorganic lens. They buried an energy source and assumed nothing would ever come to feed on it. They saw the radiation as a sterilizing agent, a perfect wall of death. They failed to see it for what it truly is to the microbial world. A challenge. An extreme selective pressure, an evolutionary forge of unimaginable intensity. On a planet where bacteria and archaea inhabit every conceivable niche, a pressure of this magnitude does not only destroy, creates. It ruthlessly culls the unprepared, leaving only the most resilient. And from that resilience, it forces adaptation. It drives evolution down new and uncharted pathways, searching for a way to turn a weapon into a tool, a poison into a food source. The absolute silence of the repository is not the silence of a tomb. It is the silence of a crucible, simmering with potential, waiting for the first spark of a new and terrible kind of fire. The sheer timescale of the phenomenon is what transforms it from a hazard into an opportunity. A volcanic vent is ephemeral, lasting centuries or, at most, a few millennia. But the energy source buried here is, for all biological purposes, eternal. The half-life of plutonium-239, a primary component of high-level waste, is 24,100 years. After 24,000 years, half of its radioactive potential will still remain. After 48,000 years, a quarter. The repository provides an evolutionary timescale that is vast, stable, and relentless. It is the perfect laboratory for creating something new, offering tens of thousands of generations for microbial life to experiment, to fail, and to finally succeed. The quiet hum of decaying atoms is a countdown, not to an ending, but to the dawn of a new biological epoch, one forged in the radiant heart of these artificial stars. The first children of this new sun are already stirring in the dark. The first colonizers of this new, radiant underworld are not complex creatures. They are ancient, single-celled organisms, carried into the repository's core by the one force the engineers could not permanently exclude: water. Over centuries, groundwater, following the immutable laws of hydrogeology, finds its way through the finest fractures in the rock, through the engineered seals and barriers. It is a slow, patient infiltration, and with it comes a diaspora of microbial life, the planet's most resilient pioneers. For billions of years, their kind has endured every cataclysm the world has thrown at them, lying dormant in deep rock, waiting for an opportunity. Here they face the crucible. The vast majority perish instantly. The gamma flux, 1,000,000 times more energetic than the light of the surface sun, obliterates their delicate cellular machinery. But they are not individuals. They are a legion of countless trillions, and within that legion lies a vast library of genetic potential. The first to truly master this domain are the fungi. In the ruins of the Chernobyl reactor, a place that remains a surface-level analog to the repository's core, scientists made a startling discovery. A black, mold-like fungus was not only surviving, but demonstrably thriving, growing directly towards the most intense sources of radiation. This phenomenon was termed radiotropism. 39. Species like Cladosporium sphaerospermum and Cryptococcus neoformans, found growing on the graphite core itself, were dark with the pigment melanin. 38. 44. This was the key. Melanin, the same compound that protects surface life from ultraviolet light, was performing a new and extraordinary function. In these fungi, the melanin is not just a shield. It is an engine. It functions as a biological transducer, absorbing the immense energy of gamma photons and converting it into chemical energy that the fungus can use for metabolism and growth. 41. This process, radiosynthesis, is a dark parallel to photosynthesis. Where a plant leaf uses chlorophyll to capture the gentle energy of visible light, these fungi use melanin to capture the violent energy of atomic decay. 40. Experiments showed that when grown in a nutrient-poor environment but exposed to radiation levels 500 times higher than normal, these melanized fungi grew significantly faster and accumulated more biomass. 38. They were, in the most literal sense, eating radiation. They are not alone. Beside them, another kingdom of life is adapting with even more astonishing results. This is the domain of the bacteria, and its champion is a species that seems purpose-built for this environment. Deinococcus radiodurans. It is often called the world's toughest bacterium, an understatement of magnificent proportions. While a dose of 10 grays of ionizing radiation is lethal to a human, and 60 grays will sterilize a culture of E. coli, Deinococcus can withstand an acute dose of 15,000 grays. This is a level of exposure that literally shatters its chromosomes into hundreds of disconnected fragments. For any other known organism, this is absolute death. For Deinococcus, it is merely a complex engineering problem. Within its cell, it holds multiple, redundant copies of its genome and a suite of exquisitely efficient DNA repair proteins. After its genetic material has been pulverized by radiation, these proteins go to work with breathtaking speed and precision. They search the cellular debris for overlapping fragments of DNA, piece them back together in the correct sequence, and stitch the strands into a complete, functional chromosome. The entire process, from genomic destruction to full restoration, can be completed in a matter of hours. This is not just survival, it is near resurrection, repeated as a matter of course. This incredible ability is not just a passive shield. It is an active, dynamic response to cataclysm. It means that Deinococcus can live and reproduce in an environment where the energy flux is constantly tearing its most vital molecules apart. This trait likely evolved billions of years ago as a defense against extreme desiccation, but here, in the constant high-energy bath of a nuclear repository, it finds its ultimate purpose. The radiation that is a universal solvent of life for others is merely an environmental hazard for Deinococcus, one its biology is supremely equipped to manage and ignore. These two forms of life, the radiosynthetic fungi and the ultra-resistant bacteria, become the founders of the radionuclide biome. They are not anomalies. They are pioneers. The fungi are the farmers, the primary producers, harvesting the raw energy of atomic decay and converting it into biologically usable forms. The bacteria are the master recyclers and engineers, breaking down any organic material that finds its way into the deep and enduring energy fluctuations that would wipe out any other decomposer. They form the base of a new, alien food web, a pyramid of life built not on sunlight, but on the slow, steady decay of plutonium. They are the Adam and Eve of this new creation, and their existence proves the builder's fatal flaw. The poison they sought to bury has become a food source. The sterile tomb they designed has become a garden. For millennia, the repository holds. Deep in the planet's crust, the engineered tomb performs its function with silent, inorganic perfection. The heat slowly bleeds into the surrounding rock, the gamma radiation is contained by layers of steel and clay, and the toxic legacy of a forgotten age remains locked away. From the surface, nothing changes. The system appears static, a problem solved and buried. This long quiet is the system's greatest deception. It is not a period of stasis, but of incubation. Life, having found a home in this impossible place, is not idle. It is adapting, multiplying, and beginning its slow, patient work. The unraveling begins not with a bang, but with the quiet hum of a billion metabolic engines. The first point of attack is the engineered barriers, the layers of human ingenuity designed to outlast empires. The models that predicted their longevity were based on abiotic chemistry, the slow, predictable corrosion caused by water and salt. But the arrival of life introduces a new, aggressive variable, biocatalysis. The children of the atom are not passive residents. They are active geological agents. Fungi, in their ceaseless search for minerals, secrete a range of powerful organic acids, such as citric and oxalic acid. These compounds are far more effective at weathering rock and metal than the carbonic acid found in natural groundwater. This process of acidolysis begins to etch the surfaces of the concrete vaults and the vitrified waste forms, creating microscopic pits and fissures where none existed before. Beneath the fungal networks, another attack is underway. Specialized bacteria begin to target the metal canisters directly. Sulfur-reducing bacteria, SRBs, an ancient lineage of microbes that thrive in oxygen-poor environments, find a paradise here. They respire not with oxygen, but with sulfates present in the groundwater, and their metabolic byproduct is hydrogen sulfide. This highly corrosive gas attacks the copper and steel of the waste canisters, converting stable metal into brittle, flaky sulfides. The protective layers, designed to last 10,000 years, begin to fail in centuries, weakened by the constant chemical warfare being waged on their surfaces. This assault is not random. The microbes organize themselves into complex, structured communities known as biofilms. A biofilm is not just a layer of slime. It is a microbial city, complete with channels for nutrients and waste, and a protective outer layer of extracellular polymeric substances, EPS. This sticky matrix glues the community to the canister surface and, crucially, creates a discrete microenvironment. Within the biofilm, the concentration of corrosive acids and hydrogen sulfide can be orders of magnitude higher than in the surrounding water. The biofilm acts like a lens, focusing the full power of the microbial attack onto a specific point, accelerating corrosion from a slow rust into a determined drill. While the outer walls are being breached, a far more profound transformation is happening within. The true danger of the nuclear waste has always been predicated on its immobility. The heavy actinides, uranium, plutonium, neptunium, are, in their solid, oxidized states, almost completely insoluble in water. The entire strategy of deep geological disposal rests on this one fact. If the poison cannot dissolve, it cannot spread. It is this fundamental assumption that the microbes systematically dismantle. They achieve this by manipulating the local redox potential, the chemical tendency of the environment to promote oxidation or reduction. Many of these extremophilic bacteria use metal ions as part of their respiratory cycle. They can breathe metal in the same way surface life breathes oxygen. In doing so, they can donate or strip electrons from the metal atoms, changing their oxidation state. Consider uranium, 4, oxide, a stable, solid, and highly insoluble component of spent fuel. Certain iron-oxidizing bacteria can strip electrons from it, transforming it into the uranyl 6 ion. This ion is not a solid. It is highly soluble in water, ready to be carried away by the slightest flow. The microbes are not just eating the prison walls. They are forging the key to unlock the prisoners. This biochemical key has more than one form. Many microbes, in their constant struggle for scarce resources, have evolved to produce powerful chelating agents. Siderophores, for example, are small organic molecules synthesized by bacteria and fungi for the sole purpose of scavenging iron, an essential but often rare nutrient. These molecules are exquisitely designed to bind to metal ions with an unbreakable grip. But they are not perfectly specific. In an environment saturated with heavy metals, these siderophores will readily bind to other atoms with similar chemical properties. They will latch onto ions of plutonium, americium, and curium. The result is a devastating synergy. The bacteria first change the oxidation state of the plutonium, making it more available. Then, their siderophores seize these newly mobilized ions, forming stable, water-soluble organometallic complexes. The radioactive atom is now disguised, wrapped in an organic cloak that allows it to travel unnoticed through the groundwater system. The poison has not only been unlocked, it has been given a passport. The unraveling is complete. The static, buried threat has become a dynamic, mobile, biological one. The repository is no longer a tomb. It has become a bioreactor, a factory for the production and dissemination of the most dangerous substances in existence. The patient, microscopic work of the children of the atom has succeeded where no earthquake could. The flood is about to be released. The breach, when it finally comes, is not a dramatic failure. It is a quiet, geological bleed. In the silent dark, miles below the surface, a single, corroded weld on a waste canister, weakened by decades of microbial assault, develops a microscopic fissure. Through this opening, a tiny amount of water, now a rich soup of dissolved radionuclides and extremophilic life, escapes into the surrounding bentonite clay. This is not a flood in the conventional sense. It is a percolation, the beginning of a slow, inexorable migration that will unfold over centuries. The poison, unlocked by the children of the atom, has been released from its primary containment. The slow flood has begun. The contaminated water does not rush. It seeps. Its movement is governed by the arcane laws of hydrogeology, following the path of least resistance through the vast, interconnected network of fractures and pores that lace the planet's crust. It forms a plume, an expanding zone of contamination that moves at the speed of geology, perhaps only a few meters per century. This plume is a mobile ecosystem, an extension of the repository biome. The extremophilic microbes travel with the water, continuing their work of altering the chemistry of their environment, ensuring the radionuclides remain soluble and mobile as they journey outward and upward. The mobility of the poison is not uniform. The different elements within the waste behave in distinct ways, a concept known as radionuclide speciation. Some isotopes, like technetium-99, are highly mobile anions that do not readily bind to rock surfaces. They travel almost as fast as the groundwater itself, acting as a swift and far-reaching vanguard for the contamination. Others, like the heavy actinides, plutonium and americium, are far less mobile on their own. Their transport is almost entirely dependent on the biological activity within the plume. They remain locked in the organic grip of microbial chelators, ferried along like passengers on a biological railway. For millennia, this process is confined to the deep, slow world of the subterranean biosphere. But the movement of water is always, eventually, upward, driven by pressure gradients and thermal convection from the planet's core. Through deep aquifers, geothermal springs, and slow capillary action, the water that began its journey in the heart of the repository finally reaches the root zones of the surface world. It emerges into a world of light, air, and a biosphere utterly unprepared for its arrival. It seeps into the soil of a forest floor. It bubbles up into the bed of a mountain stream. It joins the great, interconnected water cycle of the planet, carrying its invisible atomic payload with it. Here, in the sunlit world, the process of bioaccumulation begins, and it is lethally efficient precisely because it exploits the fundamental mechanisms of life. The biology of the surface world, having no evolutionary experience with these heavy, unstable atoms, cannot distinguish them from the essential nutrients they mimic. Strontium-90, with a chemical signature almost identical to calcium, is readily taken up by the root systems of plants and deposited in their tissues. Cesium-137 behaves like potassium, a vital electrolyte, and becomes integrated into the soft tissues of plants and animals. The poison is not just ingested. It is mistaken for the very building blocks of life itself. The plants and fungi of the forest floor, now glowing with a faint, invisible fire of their own, become the new base of this poisoned food chain. An herbivore, a deer, a rabbit, grazes on this contaminated foliage. Day after day, it consumes plant matter, and with each meal, it absorbs the radionuclides. While some are excreted, many, like the strontium, are retained and deposited in its bones. The cesium accumulates in its muscles. Over its lifetime, the concentration of radioactive material within its body grows steadily higher than the concentration in the plants it eats. This is biomagnification, the concentration of a toxin at successively higher levels in the food chain. The effect is exponential. A carnivore, a wolf, a falcon preys on these herbivores. It may consume hundreds of contaminated animals over its lifespan. With each meal, it absorbs the radioactive load of its prey, adding it to its own. The concentration takes another dramatic leap. A top predator at the apex of the food chain can accumulate a concentration of radionuclides in its tissues that is millions of times higher than the concentration in the water that first brought the poison to the surface. It becomes a living repository of radioactive waste, its very cells saturated with the strange, heavy metals that began their journey in an engineered 2 miles below. The slow flood has now reached its climax. It is no longer slow, and it is no longer confined to the deep earth. The invisible poison is now everywhere, an intrinsic part of the ecosystem. It is in the soil, preventing seeds from sprouting. It is in the water of the streams, in the wood of the trees, and in the flesh and bones of every living thing. The boundary that was supposed to last for an eternity, the boundary between the dead world of the repository and the living world of the surface, has been erased. The two biomes have merged, and the inexorable, brutal logic of the radionuclide biome is now imposing itself upon the unsuspecting world above. What is unfolding is not merely an environmental disaster. It is a geological event, a permanent alteration of the planet's very fabric. The slow, inexorable spread of long-lived, man-made radionuclides from their breached tombs into the global biosphere marks a turning point in planetary history. Future geologists, if any exist, will not need to search for this boundary. It will be an unambiguous, globally distributed layer in the rock, a thin, anomalous stratum rich in elements that have no natural place in the Earth's crust. They will call it the radionuclide spike, a permanent signature of the brief, strange reign of the species that built the tombs. This marker will be as distinct and significant as the iridium layer that signifies the asteroid impact that ended the age of dinosaurs. But where the KPG boundary marks a single cataclysmic event, this new layer signals the beginning of a slow, chronic poisoning. It announces the dawn of a new and unsettling chapter in Earth's history, the Radiozoic epoch, the age of artificial decay. This is an epoch defined not by its dominant life forms, but by the relentless, patient ticking of the atomic clocks seeded into its soil and water. The timescale of this new epoch is what makes it so profoundly different from any other form of pollution. Chemical spills eventually dilute. Plastics degrade into microparticles. Even the carbon dioxide pumped into the atmosphere will, over millennia, be reabsorbed by natural sinks. But the radionuclides are different. They are not merely a chemical. They are a clock that ticks on a cosmological scale. The half-life of plutonium-239 is 24,100 years. The half-life of iodine-129 is 15.7 million years. These substances do not go away. They do not break down into harmless components. They simply and very slowly transmute into other elements, all the while emitting their destructive energy. After 24,000 years, a span of time that encompasses all of recorded human history 4 times over, half of the plutonium will still remain. After 100,000 years, there will still be enough to be lethally toxic. The mountains on the surface will erode to dust, continents will drift apart, and ice ages will come and go, but the artificial atoms in the soil will still be ticking. This permanent elevation of the planet's background radiation initiates a new and brutal form of natural selection, a global, multi-generational stress test administered to the entire biosphere. For the vast majority of complex, multicellular life, the outcome is a slow, statistical annihilation. Chronic, low-dose radiation exposure is an insidious killer. It does not cause immediate death, but rather a systemic, generational decay. Ionizing particles constantly bombard living cells, causing sublethal damage to DNA. While cells have repair mechanisms, the sheer volume of damage overwhelms them. Errors accumulate with each cell division. The result is a phenomenon known as genomic instability. Mutation rates soar not just in somatic cells, leading to an epidemic of cancers, but critically in the germline cells, the sperm and eggs that carry genetic information to the next generation. This is the engine of the Great Dying. Each new generation is born with a greater mutational load than the last. Fertility rates plummet as reproductive systems fail. The intricate, delicate processes of embryonic development are disrupted, leading to stillbirths and deformities. Species after species enters a terminal decline, their genomes riddled with too much noise and too many errors to remain viable. The intricate web of life, woven over hundreds of millions of years of coevolution, begins to unravel. The loss of a key pollinator, a vital prey species, or a soil microbe can cause a cascade of secondary extinctions, amplifying the initial damage. But evolution does not stop. This elevated radiation is a great filter, a planetary scale test of biological resilience. In the shadow of this great dying, there are survivors. In every population, there are individuals who, by random genetic chance, possess slightly more effective DNA repair enzymes, redundant copies of key genes, or more robust cellular cleanup systems. These are the individuals who can successfully reproduce in the new, hostile environment. Their advantageous genes, once perhaps a neutral or even costly trait, are now the key to survival. Over hundreds of generations, these traits become dominant. The new selective pressure favors resilience above all else. The world is repopulated by a new caste of flora and fauna, born from the survivors. Perhaps insects, with their rapid life cycles and chitinous exoskeletons providing a slight degree of shielding, will fare better than soft-bodied mammals. Perhaps certain plants that already possessed high levels of antioxidants to combat cellular stress will find themselves pre-adapted. The fungi, the original children of the atom, will flourish, taking on new and dominant roles in the simplified ecosystems. The dawn of this new epoch is a violent and profound transformation, a forced evolution into a new and more dangerous state of being. The soft, complex, and vulnerable life of the preceding age will become a memory, a layer of fossils just below the new radioactive stratum. Millions of years pass. The planet is a different world. The continents have drifted into new configurations, mountain ranges have risen and fallen, and the very climate has shifted in ways that would be unrecognizable. The technological species that built the repositories is a distant memory, a whisper in a layer of rock, their cities and artifacts long since ground to dust and subducted into the planet's mantle. But their most significant legacy endures, thriving and evolving. The breached repositories, now fully integrated into the geology, have become the stable, beating hearts of a new and dominant ecosystem, the radionuclide biome. This is not a wasteland. It is a world teeming with a new and terrible form of life, one that has been forged, refined, and perfected over eons of relentless selective pressure. The landscape is alien. In the areas of highest radioactive intensity, vast, dark forests of radiotrophic fungi dominate, their structures reaching deep into the earth to tap the energy of the decaying waste below. The air is still, the silence broken only by the chitinous clicks of creatures whose ancestors were insects. The ground itself, rich in heavy metals and radioactive isotopes, may possess a faint, ethereal glow in the dark, a visible manifestation of the energy that powers this entire ecosystem from the ground up. At the base of this inverted food web are the descendants of the first children of the atom. The radiosynthetic fungi are now a diverse kingdom, having evolved incredibly sophisticated melanin-based roots that maximize gamma-ray absorption. The descendants of Deinococcus radiodurans are ubiquitous, the master decomposers and recyclers, able to break down the most complex organic molecules while withstanding radiation fluxes that would vitrify other forms of life. They are the foundation upon which this entire biome is built, the primary producers and decomposers of a world divorced from the sun. Above them in the food chain are the radiovores, creatures that have evolved to consume the radioactive flora. These may be slow, heavily armored grazers, their bodies adapted to process the high concentrations of radionuclides. Their biology would represent a masterclass in radiation hardening. Their cells would likely contain multiple, redundant copies of their genome, providing backups against the constant threat of DNA damage. Their DNA repair mechanisms would not be an emergency response, but a constant background process as fundamental as respiration. Some studies of organisms in Chernobyl and Fukushima have already shown the early stages of such adaptation. Increased antioxidant levels and the activation of DNA repair pathways becoming a chronic state of being 72-65. These creatures may have also evolved novel forms of biological shielding. Perhaps their shells or carapaces are not made of simple calcium carbonate, but are composites, incorporating heavy metals scavenged from their diet, bismuth, tungsten, or even lead, to provide a degree of internal protection for their most vital organs. Their metabolic pathways would be unrecognizable, featuring specialized metalloproteins designed to bind and sequester the most dangerous isotopes like plutonium and americium into inert, non-reactive forms, perhaps storing them in specific, disposable tissues or osteoderms. At the apex of this food web would be predators of terrifying efficiency. Hunting creatures whose very flesh is a concentrated source of radiation requires another level of adaptation. These apex predators might possess accelerated life cycles, reaching maturity and reproducing quickly before their own accumulated radiation load becomes lethal. 65. They might have evolved unique methods of managing their toxic burden, perhaps shedding their skin, teeth, or claws at regular intervals to purge themselves of the most contaminated tissues. In this biome, life is a constant, desperate race between reproduction and the inevitable systemic failure caused by the very food that sustains it. The fundamental rules of ecology are different here. Energy does not flow from the sun downwards. It flows from the ground upwards. The concept of poison is relative. A lethal dose of radiation for a visiting organism from a less hostile biome is a nutrient source for the native life. The decomposition cycle is radically altered. A creature's corpse is not just organic matter to be recycled. It is a concentrated packet of energy, a secondary radiation source that will continue to power the lower levels of the ecosystem for centuries after its death. The monsters are no longer monstrous. They are the logical, inevitable outcome of their environment. They are the native flora and fauna of the planet's newest, most stable biome, a world built upon the ashes of the old one. This is the ultimate legacy. It is not one of ruin, but of creation. It is a self-sustaining, autonomous world that took the most lethal poison conceived by a long-dead intelligence and transformed it into the cornerstone of life itself. The only monster here is a ghost, the faint memory of a species that possessed the power to shatter the atom but lacked the wisdom to foresee the consequences. They thought they were burying their waste, but they were only planting a garden that would outlive their sun, their planet, and their memory, a final living testament to their hubris.